the architectural model of Microsoft Azure. What's behind this whole thing that we call the cloud, right? The first thing is that we have several regions in Azure, right? We have several regions. Technically, we have 54 regions representing or spanned over 140 countries, right? That's majority of the countries. How many do we have? I think we have about 195, 196 countries in the world. And we have our data centers spanned across 140 of them, all the major countries, in fact. So there are 54 regions. And by the way, region does not mean data center. This is really important. One region, as you can see right here, you can see Canada East right here. Canada East would basically mean that, okay, there are several data centers in Canada East region. Each region corresponds to 2 to 5 data centers, right? There can be anywhere from 2 up to 5 data centers in each region, right? And all those data centers are intricately connected with each other, so that if there's a data center level outage, there's always another data center in the same region. So that is basic. That says a lot about the redundancy of the system that we have got. Redundancy is a good thing in IT. If your systems are redundant, that means your systems are fault tolerant. That means if something goes wrong, you still have something to have your back, right? So these regions provide us with the option of with flexibility and scale, right? You can scale anytime. We have a lot of data centers in each region. So if you were looking for one server and now you're looking for 20, we can do that in a matter of minutes now, because we have the infrastructure available, we have the space available in which we can do it, right? Then there is data residency can be preserved. No matter which country you're in, we can keep your data in that particular country if you want us to, right? So all the we will talk about the compliances and what are the global rules and regulations. It follows GDPR as well, uh, Microsoft Azure. So there's a lot of compliances and things like that that we undertake, right? So one of the most important things is that when you are talking about selecting a region, which region should you select? First of all, let me tell you that when you are creating any resources on Microsoft Azure, when you are requesting for anything on Microsoft Azure, maybe that could be a server, that could be storage or anything, you can select which region should it be in, right? You actually have control over that. You can select out of these 54 regions across 140 countries, right? So you can actually select that. On what basis would you select a region? Anyone? How would you select a region if I told you that, okay, you have a choice of 54 regions, select one? Anyone?
It would essentially.
One?
Yeah.
Sorry?
The closest
Could you
one.
please repeat that? The closest one, okay.
Yes.
Yes, hello.
Why the closest one?
Why?
Probably looking at the head off. Sorry, I didn't realise that you were still answering. Sorry.
Could you please repeat
Melissa,
that?
go ahead.
No, for me, I'd think about depending on where the location of the customer basically, and if they're a global customer, then perhaps the head office, because what they'll want to ensure is that regulations are in place in that particular area as well. I think it gives them some comfort in that. So potentially, yeah, look at the location of head office or office locations.
Yes,
Yeah.
mostly we can do this in two ways. First is that, okay, where are my customers? That's where I'm going to locate the server, because in that case, my customers are going to face the least amount of latency. Yesterday, we discussed latency is bad. We don't want latency in our systems. So basically, you can choose any data center, or I should not say data center. We can choose any region for our services, and that could be depending upon the end user's location, or that could depend upon my company's location. But I have to keep it into consideration that where do I want to keep this less latency, right? For most of the people, the location of their head office and the location of their customers is going to coincide. It's going to be pretty much the same location, right? So in that case, it's a no-brainer, right? But in in situations where the head office could be at a place different from where larger customer base is, 9 out of 10 times you would go with where the customers are, because that's what we are trying to do. We are trying to provide our customers with the minimum downtime and with the least amount of latency so that they enjoy our services slightly more, right? So there are global services that are region dependent. One of those services is that, okay, if you're running a particular server, if I have configured the server in East US, for example, then if somebody is accessing it from Australia, right, it's probably going to be a problem for them because it's quite far away, right? Still, that's what we are going to do. We have to select the region very judiciously, right? The cost kind of differs from region to region, right? But it's not a huge difference either. It's pretty much the same thing. Only thing that you have to keep in mind are the regulations and the latency, right? That's pretty much the only things that we keep in mind when selecting regions, right? Now, like I just said, that there are 54 regions. Most of the regions of Microsoft Azure are located near the seashore. Any idea why is that? Let me show you guys a diagram of this. Hold on. So any idea why most of the regions in Azure are located near the seashore?
No idea. Maybe because it's beautiful and calm.
That's perfect. Sorry?
Can I take a wild guess?
Yeah, please take a wild guess. That's
Maybe
what we're all doing.
maybe because of the fiber optics cables being laid below that, something like that.
That's a pretty good wild guess, by the way. That's a pretty good wild guess. Okay, hold on. Let me share my screen with you so that yeah. Can everyone see my screen now?
Yes, yes, sorry.
So 54 regions worldwide, 140 countries. You would see that most of these data centers are near the seashore, right? The idea is that you keep it near seashore. Some people might be thinking, and it's very common during the sessions, they're like, okay, seashores because data centers are huge and they could run hot, so we might need some sort of cooling. Does anybody agree with that? I know it sounds kind of stupid, but anyone? Hold on. Let me show you guys one thing. Fiber.
Yeah, I said cooling before.
So hold on. You can see these fiber optic route. Yeah. So let me see the image here. Yes. So you can see that all across the globe there's a bunch of fiber optic cables that are connecting one country to another to another. Basically, we are connecting the whole world via fiber optic cables, and those fiber optic cables kind of terminate at the seashores of the countries, because it would be kind of stupid to go actually into the country and all that stuff, right? For Russia, it kind of stops right here near the seashores. For America, it's the same thing. For Europe, it's the same thing. For the countries that are landlocked, we have other ways of transferring the data. But overall, the global connectivity is at the seashores, right? And if you compare this diagram with this one, you would see that there's one thing that's common. All the data centers are at the seashore. The reason is not necessarily to cool that down. The reason, as specified before, is that if I keep my data centers in like really landlocked locations, then what's going to happen is that, okay, the connection is fast till here, right? But I have to make another connection till right here. That's quite far. So latency would increase. We want as less latency as possible, right? So if you guys can read my screen, read the content on my screen, then you would notice this one thing. Can you notice something in the countries that these regions are located in, is there anything that's common, or is there anything that stands out? Is there a pattern or something that you see? Take about 30 seconds, a minute. In the countries where these data centers and where these regions are, is there anything, any patterns you see?
They
You've
have
got one north,
they
south,
have
east, west of the country.
Sorry?
they have got good large ports, seaport.
Seaports, okay.
You have them positioned across one in each kind of area of the country, whether it be north, south, east, west in a lot of them.
Okay, north, south, east, and west, we have countries everywhere. So first, yeah, we wanted
Sorry,
global
Sorry,
coverage.
within each country there seems to be so within some countries you'll have 4 different data centers, but positioned fairly kind of across the country, if you see what I mean.
Yeah, okay. That makes sense. But there's one thing with global coverage is that if we actually wanted like totally global coverage, there should have been more data centers in the African continent, don't you think? Except for only 2 data centers that we have now.
Maybe because of the weather, it's much more throughout Africa. It's more hotter, so it will take time to, or maybe
It's
to
actually
provide more
pretty
infrastructure.
pleasant. Africa is not as hot as most
Okay.
people expect it to be. It's actually pretty pleasant. So there's actually, you can see one more thing. There's not a lot of stuff in South America as well. And those guys have pretty awesome weather as well, right? And there are seaports that are there that are pretty much the biggest seaports in the world in South America, right? Then you can see on top there's not a lot of stuff in China. There's not a lot of stuff in Russia, right? Those are huge countries, but there's not a lot of stuff there, right? We have our data centers in Korea, but in Korea South. It's not in
Is it to
North
do with the
Korea.
regulations then of the country? Because some are much stricter than others, aren't there, in terms of what you can and
Exactly.
can't? Yeah.
Exactly. So most of the countries that you would see the regions located in, those countries are more or less politically stable, right? Or they are more, uh, yeah, I would go with the word politically stable in this case, right? So majority of the countries in Northern Africa, majority of the countries in Central Africa are not very politically stable, right? That's the same is the case with Venezuela, Argentina, that are there in South America, right? There are a lot of countries. Cuba comes to mind. There's a lot of countries there as well that are not really, you can say, politically chill, right? Same way there's sorry.
Is Turkey also considered as unstable for politics?
Oh, I'm not sure. I've not given it a thought, but we
Because
have a lot of business coming from Turkey, to be honest.
Mhm.
I would
Have
expect. I think there is something that's going on in Turkey, but I can't be totally sure about it. I read it somewhere, but I'm not totally sure if I did.
have
But
they ever
yeah,
planned? Have they ever
sorry.
planned building a data center in Turkey?
I think that's what I read, but I can't be totally sure if I recheck it because that was a long time ago.
Thank
So
you.
I would be so sure. But you can see China is there, Russia is there. Yeah, you would not, as a company, you would not want a lot of stuff to do with the regulations in those countries because you never know, right? So you can see right here, there's some in UAE North, that's United Arab Emirates. It's not Saudi Arabia, it's United Arab Emirates. That's the chill part of the Middle East, right? They are kind of uh, you can see the same thing as in in Europe you have a lot of data centers. In Northern America you have so many data centers. In Southeast Asia you have a lot of data centers right here as well. In Australia you have a few. So the data centers and the regions are decided on two things. First of all, physical location. Okay, it should be near the sea. If we don't have a sea, then we are left with no choice but to actually set up a data center where there is no direct seaport. But in most cases, that's what we look for. In another thing is that we want geopolitical stability of the region. So of course, that's where. And if you compare this with the map of how AWS data centers are located, they have fewer data centers. First of all, AWS has fewer data centers than Microsoft, but the general regions where those data centers are pretty much the same. Google, again, the same thing, but uh, they are more densely located in this Southeast Asia region, especially Google, right? They have kind of a stronghold in that region. But the idea being that regions are important, and uh, basic, basically these regions and the location of these regions is pretty important. It's pretty critical, right? So now, moving on, we have these availability options, and you can read this word right here. It's called VM. VM stands for virtual machine, by the way, if anybody does not know. Can anybody define what a VM is? Like, let's keep it very simple. What's a virtual machine? Anyone?
Is it a computer that's emulated by another computer or server?
Okay. Are you talking
It's
about?
it's a cloud-based computer, like yeah.
Okay. It's a cloud-based computer. Yeah. Actually, if we go by definition, right, the first definition was a lot more accurate, right? It's a computer emulated by another computer, maybe hosted by something else. But the second definition is, you could say, would make more sense in the context of the cloud, right? When we say virtual machine, what we mean is it's a server on cloud, or it's a computer on cloud. If I'm giving you access to the virtual machine, that means that I have created a computer in cloud, right? And I'm giving my customers the access to that particular computer so that they can install their applications, do whatever they want to do, or do whatever they would have done on their computers otherwise, right? That's what a virtual machine is. It's a simple computer. It's just a server or a computer, and we discussed this yesterday as well. Server and computer are pretty much the same thing, right? The configuration could be anything. So that's what a virtual machine is when I'm talking in the context of the cloud, or when I'm talking in context of Microsoft Azure, right? uh, Actually, there is something else called as the virtual machine as well. What is that? It's is that when you're talking about a particular server, right? There is a practice in which we can use one server and we can run multiple machines simultaneously in it. It's basically like carpooling, right? Rather than every person taking one car on one server, we have multiple servers configured. That's also called virtualization. That's also called creating the virtual machine. However, we are not talking about that. We are talking about virtual machine in context of the cloud. That means that it's just a computer and it's on the cloud. In case of Microsoft Azure, we call them as VMs. We call virtual machine as a VM, right? Uh, you would you would see some customers, they would be using this term as EC2. EC2 again is the exact same thing. It's a virtual machine, but Amazon prefers to call it EC2, right? If you are working with GCP or Google Cloud Platform, they prefer to call it as Computer Engine. So names are different, but the concept is exactly the same, right? The end user technically won't even know the difference between a virtual machine and a machine that's running in their own data center, right? If I'm working from home right now and I take remote access of my virtual machine on Microsoft Azure, it's going to feel exactly like getting control of a server that was in my data center. It's exactly the same thing. And by the way, virtual machine is IaaS, my bad, is infrastructure as a service. What does that mean? Is that it's totally configurable. You can change the configuration of the virtual machine. You can decide which software goes on this virtual machine. You can decide the operating system. You can decide how many applications and which applications you want to install. It's totally your party. You can do whatever you want to do on a virtual machine, right? So that's what a virtual machine is. Keep that in mind. This is one of the most common things that you will be talking to the customers about, right? This will come up a lot. Virtual machines will come up a lot, right? So there's one problem with virtual machines. First of all, when you create a virtual machine, by default, it's standalone. What does that mean, standalone? By default, only one virtual machine is created, right? When you are creating a machine, when you are requesting a machine from Microsoft Azure, they're going to create just one machine for you. That's all they're going to do. So if that machine goes down, okay, Microsoft promises you one thing, that okay, we were promising you 99.9% availability. That 99.9% of the chances are that okay, this is not going to go down, but there's always a 0.1%. But in that 0.1%, if this machine goes down, you will face an outage. That's what it means. Because the virtual machine is standalone, there's only one machine that's created, right? They are promising you with 99.9% availability. Is there any way to increase this availability? Anyone? How can you increase the availability of this virtual machine? You want to take it above
high
high
availability, having a redundant system. We have a backup virtual machine, then only we can increase the availability.
Okay.
Yes, you have a backup in another data center. You have another virtual machine in a separate data center.
Okay. Another virtual machine in a separate data center. But we can keep another virtual machine in the same data center as well, right? So that if my original virtual machine goes down for some reason, and the reason is not always the whole data center outage, it could just be a local outage, right? Maybe on the server in which the machine is running, right? So the idea is that in order to increase the availability, let's have another VM, right? Plus one VM plus another VM. So two VMs, that's going to increase the availability. Or basically what that's going to do is it's going to decrease the chances of downtime, right? So first of all, before we get to that, what does this 99.9% mean? Let's put this into perspective. What is this 99.9%?
Uptime.
Of course, this is uptime. But what does it exactly mean? So the idea is that it means, mathematically, it means that out of 1,000 days that I will run this machine, it can be down for 1 day. For every 1,000 days that it's running, it could be down for 1 day. That's what 99.9% means. It means 999 up days and 1 down day. That's what it exactly means. Is that good? Is that bad? What do you guys think?
It's not so good. Yeah, I mean, I've heard about 99.98 or something like that. Like even, yeah, it can be even
it's
better.
Not as awesome. It's not as awesome, right? So first of all, that earlier and not too long ago, it was like early 2010s, right? When we were talking about our data centers, we used to say, and we used to say it very proudly, that our data center has 99% uptime, or our machines have 99% uptime. Now, this sounds cool. Okay, don't get me wrong. This sounds cool. 99%, it should be pretty good. What it actually means mathematically is that for every 100 days that you're going to run this machine, it's going to be down for 1 day. Assume that this machine is your email server, right? Let's say this is your email server. Is it good? Is it bad? 99.99%. How bad is it? It's like in 1 year, there are 365 days. So basically, in 1 year, your email server is not going to run for 3.5 days. That's what we are looking at. For 3.5 days, you are not going to receive any email. There's a lot of loss to the business. That's a lot of business continuity issues. You don't want that to happen, right? So then we went to the cloud, and now Microsoft promises that we are giving you at least 99.9%, right? That means 99.90, right? Actually. So what this means is that for every year, right? If you're talking about for 365 days, what happens is that for 365 days, it's going to be down for about 8 hours. That's not really bad, right? Every year, the machine at max, now this is really important, at most it can be down for 8 hours, right? These 8 hours could be spread across 12 months. These 8 hours could happen in one day. But the idea is across one calendar year, your machine is not going to be down for more than 8 hours. That's not bad. That's actually fair, right? What can I do if I want to increase this? When I say increase, if I want to increase the uptime and decrease the downtime, technically, and we have all studied probability sometime in school, right? What it means is that if there's a certain probability of one machine going down, or if the probability of one machine staying up is 99%, why not get two machines? In that case, what will happen? That the chances of both the machines going down at the same time are very less, right? Let's get two machines rather than just one. And the chances of my machines going down at the same time are going to be quite less, right? That's what high availability means, right? So rather than going for this standalone machine, I can go with something called as VM availability set. What is availability set? That we are talking about at least two machines, at least two VMs working together, exactly the same VMs, right? And it kind of increases our uptime as well. What does it do to our uptime? It's 99. It makes it 99.95%, right? So Microsoft promises that, okay, if you are getting a standalone machine, we are going to give you 99.9% or more. That's what it means. At least 99.9% uptime. But if you're going with availability set, we are going to give you 99.95%. What does that mean? That means out of every 10,000 days, it's going to be down for, let's say, 5 days. Okay. That technically means out of every 2,000 days, it's going to be down for what, 2.5 days, right? For every 1,000 days, 1.25 days. So technically, it comes out to be approximately 4 hours. Hold on. 4 hours per year, right? So basically, the chances of the machine going down are now half, right? It was about 8 hours of downtime. In that case, it is about 4 hours of downtime in case of VM availability set. And it's going to increase as you increase the number of machines in the availability set. Your uptime actually increases, right? So there's, if you're having problem understanding what exactly am I talking about, let's compare it with your cell phones, right? You have a cell phone, and the possibility, and you want your cell phone to be highly available. You want it to be available at all costs because you have some really important phone calls to make or some really important phone calls to attend to. Let's say, what's the smartest way of increasing the chances that you always have a phone, so that if your phone is not working, you still have the phone? Get a better phone. Of course, that would make sense. But also another thing that would make sense is, rather than having one phone, purchase two phones that you use simultaneously, that you use at the same time, so that if one phone is not working, you always have another cell phone with you, right? That's exactly the scenario with availability set. Okay. Then we have something called as availability zone here as well. If I want to increase the availability in case of virtual machines, or in case of Microsoft Azure, 95%, then I have something called as availability zone, right? The copy of your machines are kept in the same data center, also in different regions. So there are multiple copies of your virtual machine that are created, so that whatever happens, right, there's a outage in the server, you already have a virtual machine in place. It's already running, right? There's an outage in the data center, you're still working. There's an outage in the region, you're still working. There's outage in multiple regions, you can still work. So the chances of the machine going down are pretty low. You can see it right here, 99.99%, right? So what does 99.99% mean? It technically means around what, 48 minutes in one calendar year. That's pretty good. 48 minutes in one calendar year, it's basically less than 1 minute per week, right? So that's pretty good. By the time the companies come to realize that, okay, the machine is down and the services are not running, that means the service would come back, right? And Microsoft ensures that, okay? I was discussing earlier that for Office 365, we have the uptime of 99.9%. That's what it does. That's what Office 365 availability is, 99.9%. So does that mean that Office 365 goes out for 8 hours? Anyone? Do you think that Office 365 goes out for 8 hours in one year?
No, that's the worst case scenario.
Amazing. That's the worst case scenario, right? It's not supposed to go more than, it's not supposed to give you more than 8 hours of downtime, right? Because that's the worst case scenario. If that happens, or if that does not work out, then Microsoft is going to pay you some money, pay you some credits, and they're going to definitely give you back some money as a token that, okay, we did not fulfill our promise in this case. So in the same way, Office 365 general availability is 99.9%. In case of Microsoft Azure, the availability is a range. If somebody asks you what's the availability of Microsoft Azure, it's a range, 99.9% to 99.99%. That's a pretty good range, to be honest, right, for the machines. And somebody was saying that yesterday for Microsoft Azure or for Office 365, it should be 99.999, and there are several nines after that 99. That's not necessarily availability. That's reliability. We use that term in case of storages, right? That's reliability of storage. What are the chances that if you save some data on Microsoft storage, what are the chances that your data would be completely wiped out? Very low chances of that happening, right? It's actually something about 99.9999, and this is called 8 nines, right? This is called 8 nines. The chances of Microsoft ever losing your data is very low, right? It's so low, it's basically, for anybody who's not very comfortable with maths, and I could be making a mistake here as well, but anyway, you get the idea. So this is the possibility that Microsoft is going to lose your data. It's technically 1 in a million, something like that, right? The possibility that Microsoft are actually going to lose something that you're keeping with them, right? This is the storage reliability, but we don't use these numbers almost anywhere, right? We still stick with availability numbers because those are kind of like the market standard as well. Okay. So these are the major availability options that we get in Microsoft Azure. We have the single VM, that's called the standalone. We have the availability set in case of failures within a data center, right? Then we have regional failures at disaster recovery, for which we have something called as availability zone, right? You can use these things to actually understand that, okay, we are securing almost all our services like this, okay? Then we have some core services and products in Microsoft Azure, right? One of the core services is the virtual machines that we just talked about. If somebody is looking for a server on cloud environment and they still want to manage the server, right? They want the exact same server that they had on premises. We are going to give them a virtual machine, right? If they have, now for you, if you're talking to a customer, if the customer is looking to host their application and they say that their application is not compatible on cloud, many people are going to say that, by the way. They say that my application is not compatible with cloud, it's not going to run, it's a very old application. We just tell them to calm down, and we tell them that you can use virtual machine. For any application that they think is not compatible with cloud, that application is going to run on virtual machines. Why is that going to run on a virtual machine? Because, as I said in the previous session, there is no cloud, right? It's just a server somewhere else. If the application can run on their server, the application can run on Microsoft's server as well. We are going to give the same environment, same operating system, the same applications. There's no reason why it would not run, right? So the idea is that if you are using virtual machines, if you're going for virtual machines, you can run any application period. You can run any operating system period. That's about it, right? So operating system compatibility, application compatibility, these things simply do not exist, right? There are some things that people say that Microsoft do not support, like old Linux operating systems and stuff like that. We do, right? And anytime you get stuck with something that, okay, is this supported on Microsoft Azure or not? If it's running on the customer servers, it's going to run on a virtual machine. If still you're stuck with something very specific, you can always reach out to me so that I can help you with that specific problem, right? So virtual machine is just a server in the cloud. It's going to work, and it's going to work as well, it's going to work as just as good as the on-prem server does, right? And by the way, virtual machine is IaaS, like we discussed earlier, right? There are some other things as well. What if the customer wants a server that scales very fast, right? They want just 2 servers right now, but they think that, okay, when we have a sale or when we have a particular date, we would not need 2 servers. We probably would need 20, right? So there would be, we have a system called as automatic scaling or auto scaling, right? So we are going to pitch them something called as virtual machine scale set. As you can see, that's number 2, virtual machine scale set. What it does is that we give an initial amount of virtual machines. That, okay, you have an initial amount of virtual machines as 2. As the load starts increasing, and we can set up the rules how we want to actually set it up. As the load starts increasing, the number of virtual machines is going to increase, so that their customers, our customers or the end users are not going to realize that, are not going to face any kind of downtimes or not going to face any kind of problems when they're accessing the applications, right? So that's what we want. We want the servers to scale rapidly, and for that we have something called as virtual machine scale set. Okay, now there's something else as well. All of these are platform as a service. So the customer, the user will actually have to install the applications by themselves, and they will have to decide on the operating systems, right? If there is an operating system update, it's the responsibility of the customer. It's the responsibility of the customer to actually update the system. If they have a malware attack or if they have a ransomware attack, just because they did not install an update, a security update, it's not Microsoft's responsibility in case of virtual machines, because when we are giving you the control, we are also giving you the responsibility, right? So if somebody is getting the virtual machines, they have a responsibility that they have to update their operating systems, or they have to install the operating system updates as well, right? So if they are not willing to do that, then we have a product for them as well. If they just want to host their application, number 1. If they just want to create their application or develop their application, number 2. In both these cases, we have just the product for them. For people who don't want to be bothered by what is the hardware like, what's the operating system, are the updates installed or not installed, who is going to install. There are some people who don't want to be bothered by all that. To them, we suggest that they use app services. You can see it right here, app services. What are app services? If you are the customer, or if you're talking to a customer and they have an application that they want to host, and by the way, most of the people, 90% of the people that you're going to be talking to, they have some applications and they have to host their application somewhere. Either you can give them a server on the cloud that can be managed totally by them, or you can give them a server on the cloud that can be totally managed by Microsoft in the backend. Microsoft is going to take care of creating the server. They are going to take care of updating the server, installing the operating system updates, making sure that the server is up and running. That's Microsoft's responsibility. The customer responsibility is only that make sure that your application does not have any bugs in it. If your application is fine, it's going to run fine. Everything else is our responsibility on Microsoft Azure. So for customers like these, we are going to give them app services. So app services is basically platform as a service, right? So if I was to compare the cost of the two things, virtual machines and app services, what do you think would be cheaper? Anyone?
Virtual machines, maybe.
Why? Why do you think virtual machines would be cheaper?
Not too sure, really, but as it's IaaS and apps, you have to pay for each one. So I think that would make it cheaper. Might be wrong though.
Okay, so fair enough. VM is actually IaaS. VM is infrastructure as a service, right? App services, by the way, app service is not actually the application. App service is a place where you can develop and you can host your application. So basically, both of these are servers, right? So first of all, VM is also a server, but you are going to manage the server. App services are also, this is also a server, but this is going to be managed by Microsoft, right? So this is basically platform as a service. So yesterday we discussed one thing when we were discussing IaaS, PaaS, and SaaS, is that you don't really pay for comfort, you pay for control, right? So there is more control. There are more things that you can change with virtual machine. There's more things that you can configure with virtual machine. And the control in case of app service is kind of less, right? So when you compare the exact same configuration for a virtual machine and for an app service, for the exact same configuration of RAM and CPU and stuff like that, right? What kind of machine that is or what kind of server that is in the backend, for exact same configuration, app service, or for the exact same configuration, PaaS is going to be cheaper than IaaS in most cases, right? So this is slightly cheaper for the customer. If they just want to host their application and they don't want to be bothered, they should go with a PaaS solution. They should go with the app service in this case. Any doubts so far for anyone? Okay. So then we have these app services and stuff like this. So we are not going to get too much into Kubernetes right now, right? That's a different thing. But the idea here is that you can.
Question. Hosting your services, what do you mean? I mean, suppose I am developing any application and I have hosted my application there in app services, right? So can my customer can use that application?
Can you repeat the last part of the question?
Can my customer, suppose if I have a customer, so can my customer use those applications which are residing in the?
Yes. Yes, it's actually hosted, right? Let me go here. So both of these, application service and VM, right? Both of these are methods of hosting the application, right? They're exactly the same in that regard. Both of them can actually host the application too. Once you are done developing the application and you host it for your end users will be able to access the application hosted on VM, or your end users will be able to access the VM. Sorry, your end users will be able to access the application that hosted in app services, right? The end user is just concerned with the application, right? When I'm taking the example of the application, right? This example could be Google, right? When I'm saying Google.com, as an end user, this is an application to me, right? I really don't know whether Google.com is actually hosted on a physical server in America, or it's hosted in a virtual machine in India, or hosted in an app service that's probably in Europe, right? There's no way for the end customer to know There's no for the end customer to know, or the end user to know where the application is hosted or how the application is hosted. The end user is just going to use that. That's about it. I hope that answers.
So,
Yatharth,
Yeah.
sorry, is there any limitation of this?
Could you please repeat that? I didn't get any of it.
Is there any limitation of end users, like thousands of only can use those applications which are residing in the platform?
Okay, what I understood from that question was, is there a limitation on the number of end users? Is that what you're asking? So, okay, let's do an experiment here. For the 1,000 users, let's say, for if you have hosted an application and there are 1,000 users that are going to use this application, you are going to require this on this machine. You are going to require, hold on, let's say 8 GB RAM and 2 CPUs, right? For 1,000 users, that's what you require, because you are hosting an application, and if for your particular application, if there are 1,000 users that are going to use that application, let's assume that's what the server's configuration is supposed to be, right? If you are hosting the same application and app services, by the way, let's say you're hosting app 1 here, and let's say you're hosting app 2 here. Let's say you're hosting the same app 1 here as well. So for 1,000 users, you are going to need basically the same configuration, right? You're still going to need 8 GB of RAM, and you're still going to need 2 GB of CPU. Oh, my bad. You're still going to need 2 CPUs in case of app services as well, right? For the same 1,000 users. What I'm saying is that for the same configuration, on the VM, if I have this configuration, and on the app service, if I have this configuration, app service is still going to be cheaper. That's what I'm saying. For the exact same configuration of the two, for the this 8 GB RAM and 2 CPU, and 8 GB RAM 2 CPU on app services, the cost of the app service is still going to be slightly less, because it's a managed service, because the server is being managed by Microsoft and you don't have the full control over the server, right? So that's why the application service is slightly cheaper. Does that make sense?
One more question. Here, CPU and so CPU is the core, right? And the RAM is the CPU, correct?
CPU is the?
So basically, it out whatever you say. I mean, how fast? I mean, what is the difference between RAM and CPU?
Okay. Difference between RAM and CPU. Okay. CPU is that how much processing power you have. CPU is how much processing power you have. Can you please mute for a second, please? It's a lot of noise coming from his side. Thank you. So CPU means that it's the processing power. The more CPU you have, or the better CPU you have, the faster you can process the data. This is basically how fast you can process the data, or how well you can process the data. RAM is how much data uh, how much data can be processed. Basically, the idea behind RAM is that how much real-time data can you process, right? If the CPU is a mouth that eats, if you're eating and your mouth is CPU, the spoon is the RAM, right? If the spoon is really small, then basically you won't be able to eat a lot. You will stay idle a lot of time while you're picking up the food and putting it into your mouth. Again, because if the spoon is very small, the food will be less, right? But the idea is the RAM and the CPU go with each other, right? The CPU, the RAM, it depends upon the CPU's capacity. So basically, when we my bad. So basically, when we combine both of these numbers together, we are talking about the performance of the machine. The better these things are, the better performance it is, right? To keep it very non-technical, it's basically the performance. So
Yes,
for more users, if I change the number of users right here and make it 2,000, I'll probably need more CPUs and more RAMs. These go hand in hand.
so Yatharth, as I can understand, please correct me if I'm wrong. that RAM, we can say that it holds all the caches of what we do on a daily basis. So whenever we use it, doesn't.
Yeah, not just on the daily basis. It's just that it holds. Okay, let me go a little technical here. Anybody who's not willing to go technical can tune out for 1 second. In this case, what's RAM? RAM is random access memory. Is that
Correct.
CPU is going to process the stuff. CPU is the processing unit. It processes the stuff. So the thing is, we have three things. Let me write it right here. We have three things: storage, RAM, and CPU.
Correct.
These are the three things that we have. Okay. So okay, everyone can join in. Let's make it very simple so that everyone understands this. Okay. CPU, storage, RAM, and CPU. Let's assume that you're in the kitchen. Okay, and you're trying to cook, let's say, an omelet. Right? You want to cook an omelet. What's the first thing you do, Deepak? You want to cook an omelet. What's the first thing you do?
The very first thing I require is an egg, then obviously the oven and everything.
Okay, so basically, let's say you have a stove in that case. On that stove, you already have the pan going on, and you want to make an omelette of, let's assume, 10 eggs, right? So the first thing you're going to do is that you're going to take an egg, you're going to break it, put it into the pan, and get to another egg, right? To the next egg, to the next egg, to the next egg, right? But the thing is, the eggs are kept in the fridge, don't you think?
Yes.
The eggs are kept in the fridge. So it would be kind of nonsensical to every time run back to the fridge, bring an egg, break the egg, put it on the stove, right? So what's the solution to that problem? The solution to that problem is I'll go to the fridge, I'll take 10 eggs out, I'm going to keep them on my kitchen counter, right? I'm going to keep them on my kitchen slab, right next to the stove, right, where I'm actually cooking, right? So actually, where you're keeping the stuff, where you're keeping most of the information, it's the storage, right? It's like the fridge, right? You're keeping most of the stuff there, but if your processor keeps on accessing information directly from the storage, right, without the RAM, let's assume that there was no RAM in this case. If your CPU was directly going for the storage, then it's going to stay idle for a long time, right? Because it's going to come really slow. You're cooking the egg, right? There's one egg that's cooking and it's already done cooking. Then you're going back, then you're coming back. It's a lot of waiting time. So we put a buffer in between the storage and the CPU. What does this buffer do? This buffer copies some information from the storage and keeps it on itself. And this storage is directly in sync with the CPU. This is a really fast storage. It's called memory, right? This RAM is currently in sync with the CPU. So whatever applications that you're going to run, if you have 20 applications running on your computer, if you have 20 applications installed on your computer and you're just going to run, let's say, 2 applications, then these 2 applications will come from storage to the RAM so that CPU can actually access them really fast. So this is a buffer space where the processor can access the information really fast. This is a buffer space, right? And it's different from storage because storage stores all the information. RAM stores the important information, or RAM stores the information that is currently in use, so that the CPU does not have to wait for the information to come from the storage. It's a buffer.
The caches that I was talking about.
Exactly. Yeah, that's what happens. The caching happens. Caching happens in this case, but I tend not to use this term caching because caching happens in storage as well, right? So that's a confusing term in this situation. We just call this as memory.
Okay.
We don't call it cache. We call it as memory. So there's a difference between your storage and your memory, right? Your memory is something that you are using in real time, right? Your storage is that, okay, I've stored the stuff, I know it is there, but right now I'm not using it. Memory is just the stuff that I'm using right now, right? And the combination of these two, RAM and CPU, decides how good the performance of a system is going to be. If your RAM is really good and your CPU is really poor, the performance is going to be poor because again, you have a lot of eggs, but you're cooking them really slow. It's a slow performance, right? And by the way, if your CPU is really good and your RAM is really small, let's say you have 4 CPUs and 2 GBs of RAM, that means uh, your CPUs have a lot of capacity, but you cannot hold a lot of data with yourself. So that's also going to decrease the performance because the CPUs are going to wait for the data to come in because there's not a lot of data that can actually reside on the RAM in real time, right? I hope this clears it up.
Yes, thank you.
So what I'm saying is that when I'm talking comparing VMs and app services, the comparison is between IaaS and PaaS, right? Whenever I'm comparing IaaS and PaaS with each other, that basically means that PaaS is going to be slightly cheaper for the same configuration. Why? Because Microsoft are taking care of it. That means that on that same server, Microsoft could be running some other people's application as well. In this VM, because this VM belongs to me, right? This VM belongs to a single person. They are just going to run their application. This VM has to be dedicated to a particular person, right? But this app service could be part of a bigger machine on which multiple people are running their applications. But we do not really have to know who else is running the application because, again, who has to? Nobody has to know that, okay, other people are running the applications because Microsoft is hosting everything, right? And they're just giving you the configuration that you require. So that whole process becomes slightly cheaper. So you can compare it with economies of scale as well. There are multiple people using the same resource, and there's only one person using this particular resource. The cost is going to be slightly different. Okay. So yeah,
I'm sorry to interrupt you.
Yeah, go on.
I just wanted to know, since you mentioned that other applications would also be running on the same platform if we go for a PaaS setup. I just
Okay.
wanted to understand that are these applications containerized, as in the sense that
They
if
are
one
totally
application,
isolated from each other. They are
yeah,
totally
okay,
isolated from each
okay, okay, okay.
other.
Thank you.
If you are running, or if your customer is running or going for an application service for app 1, some other user might be running app 2 totally different on that same location, but we are not going to know. Nobody else is going to know other than Microsoft. And since you use this term containerized means that these applications are totally isolated from each other and they are not going to interact with each other in any way. They're not going to access each other's data. They're not going to access each other's computing, or they're not going to clash with each other. Right? Microsoft makes sure of that. Right? So that's what happens with the application service. That's why it is kind of cheaper for most of the people, because everyone is it's like the bus. Rather than taking a cab, you are taking a bus, right? So it's like that. So multiple people are still traveling from place A to place B in case of app service. Okay. So hold on. Let me go over here. Yeah. So basically, Azure Compute has a lot of components. We are majorly going to use 2 of them. We are going to use virtual machines, and we are going to use app services in general. Okay. Then these are the 3 things I just told you. Infrastructure as a service is Azure VM. It provides you the computing power. If you want to scale these VMs, if you want multiple servers for a particular location, you should go with VM scale sets. If you are looking for a platform as a service environment, you want everything that's being managed by Microsoft, and what you want to bring is your own application. That's all you want to bring. Go with application services, nothing else, right? In this case, you have another advantage. You can build your application as well. You can develop your application as well from scratch, right? It gives you the tools and stuff like that. We'll get to the functions part later on, but functions is very much similar to application services. It's also a platform where you can run your application and develop your application, but it's slightly different. Okay, next thing is Azure Marketplace. whatever resources you're going to use on Microsoft Azure. And what's a resource? If you're getting a virtual machine, if you're